So following on from the previous video, we got to this stage here where our graph looks like this. And at the end of the previous video, we said that there was something happening between here and infinity here. Something is happening in between here and here. Something is happening here. And I said that you can't really detect it with your naked eye. The only way you can detect it is by looking at the second derivative. So let's now look at the second derivative. So looking at from the previous video, we worked out the first derivative. So now let's look at the second derivative. So now differentiate this. Okay, so differentiate this. So just follow it through. So blah 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 blah, blah 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 blah, blah blah blah, and then blah blah blah. So our second derivative turns out to be this. Okay, so now so as I said, something is happening in between, somewhere around here, in between here and here, and the way you can detect it is by looking at the second derivative here. So now let's look at the second derivative. So find out when the second derivative is 0. That's the interesting point. So looking at this here, find out when the second derivative is 0. So hang on. Remember from some of the earlier videos, if the second derivative is greater than 0, you will have a concave up. Okay, and we've done several videos on this. If the second derivative is less than 0, you will have concave down. So your graph will your original function f of x will concave down. If the second derivative is greater than 0, your original function will concave up. Okay, and when it's dead on 0, well, in our case, this is what's happening here. In our case, we've got concave up, and then when f of x when f double prime equals 0, you have what's called an inflection point here. So here you've got the second derivative here is greater than 0, and then over here the second derivative is less than 0, so you have concave down. But the thing is, it's concave down in such a way that it's still heading towards positive infinity. You can see that here it's concaving down, but yet it can still head towards positive infinity. So in our situation here, we've got we've got the second derivative being less than 0, so it's concaving up here, and then past the inflection point, it concaves down, but it's still heading towards infinity. So going back to here, we know something. Well, we know something's happening in between here, and the way we can tell is by looking at the second derivative. So find out when this thing here equals 0. Okay, so now our next aim here is to try and find out when this thing here equals 0. So looking at this, okay, so looking at this, hang on, looking at that, hang on. So looking at that, we now want to find out when this thing here, looking at that here, we now want to find out when this equals 0. So set this thing to be 0, and then find the value of x when f double prime equals 0. So now imagine this as one bubble, this here as another bubble here. So times both sides by this bubble here. That will then give you this. Okay, and then add natural log of x to both sides, and then exponentiate both sides. That will then give you this. These two will kill off each other, leaving you x equals e squared. So what that means is that at x equals e squared, so what that means is at x equals e squared here, our inflection point is right here. Our inflection point is right here. So what's happening here is that you've got concave up, and then by right it should concave down, but it's still heading towards infinity. But just know that the inflection point is when x equals e squared. So the coordinates here would be e squared, comma, something. Now we're going to work out this something here. Okay, so looking So looking back at our original function here, let's put e squared into the original function. That would then put e squared in here, and then put e squared in here. That will then give you this. Okay, so so this thing here just becomes 2. Okay, well, when you're here, you can visualize it like this. You can, if you want to, visualize it like this. This 2 here goes down here, so that becomes 2 natural log of e to the 1, if you like, and then these 2. Well, this thing here becomes a 2. Okay, so f of e squared is this thing here. So the coordinates here will be the coordinates of our point of inflection here will be e squared comma e squared over 2. So the coordinates right at our point of inflection is right here. I will elaborate more on this in the next video. Okay.